Hi guys, Mrs. H here. So today we're going to be continuing on looking at terms that describe motion. Specifically, we're going to be looking at speed and velocity. So speed, this is one you're familiar with. We hear this, oh, what's the speed of the car? How fast was he speeding? This is in our day-to-day vocabulary, but let's really look at what we're doing when we're describing speed. So by definition, speed is distance divided by the time during which the motion occurred. We can also say that speed is equal to distance divided by time. So one we're using words and one we're looking at it algebraically. Remember, if we look at this in an equation, so S equals D over T, which S is speed, D is distance, and T is time. The value is describing how fast or how slow an object is moving. Because all we're looking at is a magnitude, this value is scalar. And an example of this, a car travels 60 kilometers in 6 hours, or a car has a speed of 100 kilometers per hour. So this is what we see on a speedometer. So a speedometer is describing all of these things. Now with speed, we have some ways we can describe speed. One is a constant speed. So a constant speed means that the speed is not changing over a duration of time. How long that duration is does not matter. So it's, at 10 seconds, at 20 seconds, at 30 seconds, the speed has not changed during those periods of time. So an example of this, planes travel at their cruising altitude, that's a constant speed. Cruise control is a constant speed. Or if you are driving on a road and you go 25 miles for 20 minutes, or you're driving on the highway and you set your cruise control and you're traveling 60 miles per hour for 2 hours. We can also look at constant speed on a position time graph, where the slope is a measure of the constant speed. And so because the slope isn't changing, we can see that this is measuring a constant speed. So here's an example. Notice the slide is gray, so you're going to be required to do some work here. So your car travels 30 kilometers to your grandma's house in 6 hours, or your car is traveling 60 kilometers per hour. Oops, that should be 50. Excuse me. Okay, so the first thing we need to do is identify our variables in the equation. So we have 6 hours, so that's time. We have 30 kilometers, and that's distance. And then we have 50 kilometers per hour, which is speed. So using the equation D divided by T equals S, we need to fill in the equation. So D right here is 300, so we put 300 into the D. We have a time of 6, so we put 6 down here. So 300 divided by 6 is equal to 50 kilometers per hour. So now it's your turn. So we've got problem number 1. How far can a biker travel if they ride 12 kilometers per hour in 9 hours to California? And how long does it take a ship to go 2,400 kilometers if it travels at a speed of 40 kilometers per hour to Key West? So go ahead and practice this now on your own. Okay, so what do we get here? So notice we have to identify our variables. So we have 12 kilometers per hour, which is our speed. We have 9 hours, which is our time. So we need to put those two variables into the equation. D divided by T equals speed. So it's D divided by 9, so divided by time, equals 12 kilometers. So then we need to rearrange the equation to solve for D. So I need to get rid of the 9 on both sides. So I need to multiply both sides by 9. And so my distance is 108 kilometers. So problem number 2, again, I need to identify my variables. 2,400 kilometers, that is your distance. 40 kilometers per hour, that's your speed. So again, placing it into the equation. Like so. You can also use d divided by s equals t. Either way is okay, whether you put it into the equation or rearrange the equation first. I don't care which one it is. And so that's how we would do it on both of these. And so we end up with 60 hours. So again, the first equation we are solving for distance. The second equation we're solving for time. So now we have a definition of average speed. Average speed is the total distance traveled by the object divided by the elapsed time to cover that distance. It's also scalar. So that means we're only looking at a magnitude on this. So here's an example. So I went to my house, and then I went to the diner, and then I went to my friend's house. And so what would be my average speed on this? So I need to calculate my total miles traveled and my total time. So I have 5 plus 15 plus 15, and then my total hours. I have a half hour and a quarter of an hour and another quarter of an hour. So I traveled a total of 35 miles in 1 hour. So that would be my average speed. Does that mean that's what I traveled the entire time? No, I could have had an instantaneous speed of 0 at one moment if I was stopped at a stop sign. I could have been traveling 60 miles an hour if I was on the expressway. I could have been traveling 45 miles an hour if I was on say a larger street, like maybe Anthony Wayne Trail. So again, this would be my average speed, not this made up of instantaneous speeds along the way. So again, instantaneous speed is how fast we were going at any given time. So your speedometers on cars tell you your instantaneous speed. If we were looking at that on a graph, it would be the speed at one specific time. So one moment in time, how fast were we going? Where the average would be over the entire period of time. So a way to look at this one, this is now velocity. So what's the difference between velocity and velocity we describe as a rate of change. So this is a change in position over time. And the big thing we need to remember, this includes direction. So we're velocity, we're looking at displacement over time. Speed is distance, where velocity is displacement. So this is a scale. This is not scalar. This is vector. So velocity is by definition a change in position over time. Remember, when we're looking at position, we also are including direction. So if I say someone is running 2.5 meters per second to school, we are actually giving a velocity because we're including a direction there. Your direction doesn't have to be a specific north, south, east, west. It can be in relation to a reference point. Okay, so now let's look at how this would be different mathematically. So again, you're going to be doing some work here because the slide is gray. So you travel 300 kilometers in 6 hours to Cincinnati. What is your velocity? So again, we're looking, velocity is the change in position over time plus direction. So I have 300 kilometers is my distance. I have 6 hours is my time, and I need to include our direction. So Cincinnati is south, so I'm moving in a direction of south. So 300 divided by 6 is 50 kilometers per hour south. And that would be how we solve our velocity. So what would be different here in my velocity problem? So if I'm looking for my average velocity, so again, I'm going to my friend's house and going to the diner. The difference here is what is my displacement? Well, I started at home and I ended at home, so it's 0. I did not have, my displacement is 0. So my average my average velocity here is 0 miles per hour. Even though I moved, my velocity is 0. And I know that's really hard to think because, well, wait, you were going 35 miles per hour. Well, that was speed. My velocity is in a change in position. So because I did not, where I started and where I ended makes my displacement 0, this makes my velocity 0. So now here we have a gray slide. So you have some practice problems here. So problem number 1 and problem number 2. So what's going to be the difference in the wording? So this we're doing velocity where before we did speed. So take a moment to go ahead and solve these problems. And so what do we do? Again, we identify our variables. We place our variables into the equation, but this time notice we have the direction east because I'm going to California. Wait, that should be west. Excuse me. California is west, so we're traveling west. And so it's our answer would be 108 kilometers west. How long does it take a ship to travel? Again, we're identifying our variables, placing them into the equation. But again, this time we have a direction, so we're going to Key West, so it would be south. And so notice our differences in our answers between our speed and our velocity. When it was speed, we didn't include a direction. Now that we're dealing with velocity, we have to include a direction. So I hope this was helpful. If you have any questions, make sure you're reaching out to me. Bye, guys.